myself Dr. Anuj Purwar. Today I am taking lecture on sources and collection of water part 3. Shallow wells. These wells are in the upper layers of the earth's strata, usually less than 30 meters deep. The amount, distance and nature of immediate pollution and the character of underlying strata determine to a large extent the purity of such type of water. Location of shallow wells with respect to known pollution source becomes of prime importance in the use of water, especially when large quantities are to be withdrawn. Deep wells. A deep well is one which rests on an impervious layer and draws its supply from the pervious formation lying below through a borehole made into the impervious layer. The impervious layer may be continuous or sometimes localized and found of varying thickness. These wells are frequently polluted through the surface openings. Newly constructed well shows pollution from the drilling operations which include surface matter. Yield of a well. When a well is drilled or dug into an homogeneous aquifer, the water table initially is horizontal in the well. When the well is pumped and water is removed, the water table or piezometric surface, depending upon the type of the aquifer, is lowered, resulting in a circular depression in the water table or the piezometric surface. This depression is known as cone of depression or the drawdown curve. At any point away from the well, the drawdown is the vertical distance by which the water table or the piezometric surface is lower. There are several methods for estimation of yield of groundwater, but the best method is by means of actual pumping test carried out on for a sufficient length of time so that on state of equilibrium is achieved. Type of aquifer. Aquifers are mainly of two types: unconfined aquifer and confined aquifers. Unconfined aquifers or water table aquifer is the one in which water table is the upper surface of the zone of saturation. It is also known as the free phreatic or non-artesian aquifer. Confined aquifer or artesian aquifer is the one in which groundwater is confined under pressure greater than atmospheric by overlying relatively impermeable stratum. This is a picture of the unconfined aquifer. To get the discharge formula for the unconfined aquifer. So here curved line indicates the profile of water which is shown after a few hours of pumping. Its inclination is so small that its tangent can be used in place of sign for the hydraulic gradient in Darcy's equation. Here small rw is equal to radius of the well, capital H is equal to thickness of the aquifer. This is measured above the impermeable layer to the initial level of water table. Small dw is equal to drawn down of the well. Small hw is equal to depth of water in the well measured above the impermeable layer. This is equal to capital H minus small dw. Considering the origin of coordinates at a point O0, which is the center of the well at its bottom. Coordinates of the any point P on the drawn down curve is RH. From Darcy law, Q is equal to KIA. Here Q is equal to discharge, K is equal to the coefficient of permeability of the soil, small I is equal to hydraulic gradient, which may be here as dH divided by the dr. A is equal to area of cross section of the saturated part of the aquifer. So area A is equal to 2 pi r into h. So Q is equal to K I means dh upon dr, and area 2 pi r h. So we here we got the Q dr upon r is equal to 2 pi k dh. Integrate both sides. In left side with limit r1 to from r1 to r2, and in right side limit from h1 to h2. So we got Q log E in bracket r2 upon r1 is equal to 2 pi k in bracket h2 square minus h1 square divided by 2 is equal to pi k in bracket h2 square minus h1 square. So Q is equal to pi k in bracket h2 square minus h1 square divided by log E in bracket r2 divided by r1 is equal to 1.36 k in bracket h2 square minus h1 square divided by log 10 in bracket r2 divided by r1. Now this is in log 10. So Q is equal to 1.36 k in bracket h2 plus h1 into h2 minus h1 divided by log 10 in bracket r2 divided by r1. Then this is equal to 1.36 k into 2h into s1 minus s2 divided by log 10 in bracket r2 divided by r1. Here we will discuss the how we kept here 2h in place of h2 plus h1, and we kept s1 and s2 in place of h2 and h1, and so Q is equal to 2.72 t s1 minus s2 divided by log 10 divide into in bracket r2 divided by r1. So in compared to stratum thickness h, draw down is very small, hence h2 may be taken nearly equal to the h1. So T is equal to and T is equal to K capital H is known as coefficient of transmissibility. S1 and S2 are the values of drawdown at R1 and R2 respectively. If K is expressed in cubic meter per day per square meter of the area of subsoil, then the discharge will be in cubic meter per day. Confined aquifer. In figure, a well fully penetration through a confined artesian aquifer of thickness Z. It is shown here. So now we will get the formula for confined aquifer. Here the area of flow A is equal to 2 pi r Z. So Q is equal to K into dH upon dr into 2 pi r Z. In same way, then dr upon r is equal to 2 pi k Z dh. Now integrating both this question both sides with the limit r1 to r2 and h1 to s2 as we have seen earlier. So here Q log E r2 divide r1 is equal to 2 pi k z in bracket h2 minus h1 is equal to 2 pi k z and in capital S, where h2 minus h1 is equal to s we kept here. So Q is equal to 2 pi k z s divided by log E in bracket r2 by r1. So k z is equal to T is equal to coefficient of transmissibility. Q is equal to 2 pi Ts divided by log E in bracket r2 divided by r1 is equal to 2.72 Ts divided by log 10 in bracket r2 divided by r1. So it is equal to 2.72 T in bracket s2 minus h1 divided by log 10 in bracket r2 by r1. Yield of an open well. The hydraulics of a line well is different from that of a tube well. The yield from an open well may be obtained by the test constant level pumping test and recuperation test. Constant level pumping test. In this test, water is pumped from the well at a rate so as to maintain a constant drawdown. Pumping is done at a large rate at the initial stage till the condition of maximum safe working head is reached. The rate of pumping is so adjusted that water level in the well remains constant for a number of hours. In this condition, the rate of pumping equals the rate at which water percolates into the well. The discharge from an open well with impervious lining is equal to Q is equal to A into V. This is equal to A into C into H. Here Q discharge in meter cube per second. A is equal to cross sectional area of flow into the well. This is in meter square. V mean velocity of the water percolating into the well. This is in meter per second. H is equal to hydraulic head. This is in meter. C is equal to percolation intensity coefficient. Its value is greater for coarser soil and finer soil. This is in meter per second. So here the picture for the constant level pumping test. Recuperation test. In this test, water level is depressed by pumping to any safe level below the normal level. Pumping is then stopped and the water in the well is allowed to recover to its original level. The gradual rise in the water level is observed at brief intervals of time. Let the yield of the well is proportional to drawdown or depression head. So Q proportional to small h, or we can say Q is equal to KH, where K is the constant. Considering the rise in water level is H in the well at time t after stopping the pumping. This is represented by the line XX. At a time t plus t dt, rise in water level in H plus dH. This is shown in the line YY. So this is the picture for the recuperation test. So the amount of water V which percolate into the well in the time interval dt is then V is equal to A dH. So we can say in place of A we kept the Q, so V is equal to Q dt. We can say like that also. So V is equal to A dTH is equal to Q dt, yeah, or we can say A dTH is equal to KH into dt. So, or we can say K divided by A is dt is equal to dH upon H. Now integrating both sides with limit limit t is equal to 0 to t is equal to capital T, and H is equal to H1 to H is equal to H2. So we got the result capital K into capital T divided by A is equal to log E H2 upon H1. Now converting in log 10, this is value is equal to 2.303 log 10 H2 upon H1. So here K is equal to 2.303 A capital A divided by capital T log 10 H2 divided by the H1. Now interference among wells. As per Dupit, two separate observation wells are not drilled. If two or more wells are dug nearer to each other, their cone of depression will intersect and they are said to interfere. Such mutual interference decreases the discharge. Muscat has given equation for evolution of discharge in such interfering cases. So here the picture to get the that formula. So for confined aquifer, for two identical wells at a distance L apart, then Q1 is equal to Q2 is equal to 2 pi K D in bracket H minus H divided by 2.3 log 10 in bracket R square divided by in small r in capital L. For three identical wells at distance L apart in a pattern of equilateral triangle, then Q1 is equal to Q2 is equal to Q3 is equal to 2 pi KD in bracket H minus H divided by 2.3 log 10 in bracket R cube divided by R L squared. For three identical wells at distance L apart in a straight line, then Q1 is equal to Q3 is equal to 2 pi kd divided by 2.3 in bracket into h minus h, capital H minus small h into log 10 L divided by the R. Divide whole division by the log 10 RL, log 10 L upon R plus log 10 L upon 2R into log 10 R upon small r. And in this situation, Q2 is equal to 2 pi kd divided by 2.3 into in bracket h, capital H minus small h into log 10 in bracket L upon 2R. Divide by the 2 log 10 in bracket capital R divided by capital L log 10 in bracket capital L divided by the small r plus log 10 in bracket capital B divided by 2R log into log 10 in bracket capital R divided by the small r, where Q1 and Q3 are the discharges through the outer wells and Q2 is the discharge of the middle well. For unconfined aquifer, the case is called for gravity well also. For two identical wells at a distance L apart, then Q1 is equal to Q2 is equal to in bracket pi k in bracket h is capital H square minus small h square divided by 2.3 log 10 in bracket r square divided small r into capital L. For three identical wells at distance L apart in a pattern of equilateral triangle, in that case Q1 is equal to Q2 is equal to Q3 is equal to in bracket pi k in bracket capital H square minus small h square divided by 2.3 log 10 in bracket r cube divided by the small r capital L square in bracket close. For three identical wells at distance L apart in straight line, in that condition Q1 is equal to Q3 is equal to pi k divided by 2.3 into in bracket capital H square minus small h square into log 10 capital R capital L divided by small r and whole divided by the log 10 in bracket capital R divided by capital L into log 10 in bracket capital L divided by small r plus log 10 in bracket capital L divided by 2r into log 10 in bracket capital R divided by the small r, and Q2 is equal to pi k divided by 2.3 into in bracket h capital H square minus small h square into log L divided by the small r. Whole divided by the 2 log 10 in bracket capital R divided by the capital L into log 10 in bracket capital L divided by the small r plus log 10 in bracket capital L divided by the small 2r into log 10 in bracket capital R divided by the small r, where Q1 and Q3 are the discharges through the outer wells and Q2 is the discharge of the middle well. So this is the case of the unconfined aquifer. So here we will discuss some example on that aquifer. Example, a well having a diameter of 15 cm has been drilled in a confined aquifer having a thickness of 12 meter. Radius of influence is 350 meter from the center of the well. If coefficient of permeability of soil is 15 meter per day, find the discharge in the well for a drawdown of 2 meter. So here formula is Q is equal to 2 pi small k in capital D into in bracket H capital H minus small h divided by 2.3 log 10 in bracket R divided by the small r. So put all the value here. Q is equal to 2 pi in here the coefficient of permeability of soil is given 15 meter per day, so put here 15 into D is given diameter 15 centimeter into D is thickness is given 12 meter, so put here 12 meter, and then drawdown value is 2, to multiply by the h minus h is equal to 2, divide by 2.3 log 10. In place of r, kept the radius of influence is equal to 350 meter, divide by the small r in meter. So here the d is given is the 15 centimeter, so it is the in meter 0.15 meter. So it is, so small r is equal to the d divided by the 2, so put here value 0.075 and simplify these values, so we get the answer q is equal to 268.15 meter cube per day. Here the second example, a 20 centimeter diameter well was drilled 20 meter below the static water table. In two observation wells at a distance of 80 meter and 35 meter from the center of the well, the water level was found to be lowered by 50 centimeter and 110 centimeter respectively at a discharge of 6000 liter per minute in 24 hours. So calculate the transmissibility of the aquifer. So here the formula Q is equal to 2.72 kH in bracket S1 minus S2 divided by log 10 in bracket R2 divided by the R1. So T is this is equal to the 2.72 T equal this is equal to the 2.72 T. We place the T in place of the K into H. In bracket multiply in bracket S1 minus S2 divided by log 10 R2 minus R1. So T is equal to then Q into log 10 in bracket R2 divided by R1 divided by the 2.72 into in bracket S1 minus S2. So here Q is given 6000. So put the value here in meter per minute. So 6000 divide by the 1000 meter cube. Here value kept in meter cube into log 10. R2 is equal to given 80 and R1 is equal to 35. Divide by 272 into in place of S1 kept the value 1.1 meter or 110 centimeter and in place value of 0.5 meter or 50 centimeter in place of S2 and calculate the simplify this calculation. So value come T is equal to 1.33 meter square per minute. Here the another example, to determine the specific yield of a well of 0.5 mm diameter, recuperation test was done when the normal water level was found to be 7 meter below ground level. Pumping decreased water level to 12 meter below the ground level. The water rose to 10 meter below ground level after 4 hours of stopping the pumping. So calculate the specific yield of the well and second yield under a drawdown of the 3 meter. So for the first case use the formula K is equal to 2.303 capital A divided by the T into log 10 into small h2 divided by small h1. So here A is equal to pi into radius 0.5 is given, divide 5 square divided by 4. So answer come here 0.1965 meter square. So here some mistake is given. So here the value is the diameter is the 5 mm. 5 this is given 50 centimeter. This is or given 0.5 meter. So T is equal to 4 hours put here and H1 is equal to 12 minus 7, this is 5 meter, and H2 is equal to 10 minus 7. So this is the value is 3 meter. Put the value of H2 and H1 here and the value of the A. So we got the value K is equal to on simplification K is equal to 0.0251 meter square per hour. And now in second question here yield under a drawdown of the 3 meter. So in that case, Q is equal to, we got the K value K in first part. So Q is equal to K into H. So K value 0.0251 and H is equal to given 3. So answer is that 7.53 meter cube per hour. Here another example. In order to determine the average permeability of a bed, sandy soil 40 meters thick overlaying on an impermeable stratum, a well was sunk and pumping test was carried out. After an interval of time, the discharge was 12.4 liter per second and the drawdown in the observation wells at 16 meter and 33 meter from the pumping well were found to be 1.787 meter and 1.495 meter respectively. If original groundwater table was found to be 2.14 meter below ground level, find out the coefficient of permeability of the soil. So formula is K is equal to 2.3 Q log 10 R2 divided by R1 divide by pi in bracket H2 square minus H1 square. So R1 is equal to 16, R2 is equal to 33 meter, H1 is equal to 14 minus 2.4 plus 1.787. So answer comes 10.073 meter. In second case, H2 is equal to 14 minus in bracket 2.14 plus 1.495, then is equal to 10.365 meter. So Q is equal to, and Q is equal to given 12.4 liter per second. So converted in the meter cube per day. So it is Q is equal to 1071.36 meter cube per day. So K is equal to, put out the value here, the value of 2.3 into Q, in place of Q this is 1071.36 into log 10, in place of R2 33 and place of R1 this is 16, divide by pi into in bracket S2, in place of S2 10.365 whole square, in place of H1 is H1 square 10.073 square. So on simplification value comes the K is equal to 41.32 meter per day. Now if we can convert it in a centimeter per second, so answer comes the 0.0478 centimeter per second. So it is all about the this lecture. Thank you.